Hi, I'm Katie, and I have just reached my second milestone on my Forearm computer, which is getting the GPS and the compass to work with the TNC board. So this is the way my project looks right now. This here is, again, the weather sensor, the humidity sensor, this here is the TNC, and I replaced the Arduino Uno for my last milestone with the TNC because the TNC is both smaller, so it'll fit on my Forearm computer, and it's also more powerful because it has a different processor. So the TNC works the same as an Arduino, though, reading data from the sensor, performing calculations, and sending out data to the screen. And this, again, is the screen. This here is the GPS. The GPS can similar to any GPS, it tells you where on Earth you are, and it can also tell you it can tell you your altitude, and it can tell you your speed. The GPS works by communicating with the satellites that are orbiting in the sky. The satellites send to the GPS their location and the time, and using at least 3 satellites, the GPS can tell where on Earth it is. And with the 4th satellite, the GPS can tell the altitude that it is at. The GPS communicates with the TNC using a serial communication, which is similar to that the TNC would communicate to the computer with the USB. And the TNC has a couple of serial ports, which allows a device like the GPS to communicate with it. The GPS then sends its data to the TNC, and the TNC can send that data to the screen and display things like latitude, longitude, altitude, speed, the number of satellites it is connected to, the time since the last update. This here is the compass. So the compass works, communicates also with I2C, similarly to this weather sensor, and basically it can sense the magnetic field at a certain point that is caused by the poles, so there it can tell in which direction the 2 poles are. So the compass sends its heading, the direction it's pointing, to the TNC, and the TNC displays it on the screen. The compass needs to be completely parallel to get a correct reading, parallel to the ground. So that'll be something I have to consider when I'm building my computer. Also, you can buy a compass that uses a accelerometer to tell you if it's tilted or not, and compensate that in the calculations, but this one doesn't have that. So the compass and the GPS and the weather sensors also have their data sending to the screen. So in order to be able to display all of this, I use the button to cycle through different screens, such as the weather screen, the GPS screen, and the compass screen, as well as a home screen. So the button, initially I was using the button to just whenever it was pressed to send a signal to the TNC, and it can tell when it's pressed because when it's pressed it connects this pin and this pin. So if this pin is connected to the voltage and this pin is connected to ground, when it's pressed they'll be connected, and the TNC will read that there is voltage coming from the button. So initially I just had it, when it read, it would switch the screen, except there was so much data coming into the screen from the sensors that sometimes it would sort of miss over the button, or it would be so delayed that the button wouldn't change the screen. So instead I used something called an interrupt, which basically when the button is pressed, it interrupts whatever the code is doing, and it just and it changes the screen, which is a lot more effective. So this here is the GPS working. This is the GPS, and it needs to be by the window to get a signal. The GPS sends the data to the TNC, which then sends it to the screen. This is our current latitude, longitude. The fixed age tells you how many milliseconds since the information came from the GPS, and this is the date. The GPS can also print other pieces of data that aren't printed here. This here is the compass working. This is the compass. It sends the data over I2C to the TNC, which then sends the reading to the screen, and when you turn it you can see that it changes, and the compass needs to be exactly parallel to the ground to get a correct reading.